So page 492.
492?
Yeah.
Okay, let's try again. Like that one. Website. I wonder if anybody's told him that this does this. Maybe it only does it under Google Chrome. 492.
Yeah.
There we go. Where do you want to start?
So problem 37. And so my teacher did 4 individual problems. So 37 is the first one.
Okay. Describe the transformation of the graph of f represented by the function g. Now, you're obviously into trig sinusoid functions, right? Or not? Is this your first experience with sinusoid functions?
Yes.
Okay.
Well, with them, yes.
All right. Well, now you're taking the limited amount of trig that goes with algebra 2, or are you taking more trig than that?
Just the algebra 2 trig.
Okay. Because there's a couple ways you can go here. When they are teaching you a full trig course, they're going to teach this one way. When they are teaching it as part of algebra, they're probably going to teach it a different way. By the sinusoid function, let me just draw it in case it looks familiar. It's y equals a sine of b times x minus c plus d.
Okay. Yeah, that's pretty much what my teacher did.
Okay.
But he did f of x equals a times, and then we didn't actually get to sine. He did cosine first.
Well, believe it or not, this is called a sinusoid function, and you can use either sine or cosine. Doesn't matter. Even 37 is a sinusoid function.
All right.
Okay. Now, the one thing that's always puzzled me about trig is that when they teach this to you, they don't treat it like transformations of polynomials, which I don't get because everything is a transformation of a polynomial. Now, terminology, what do they call that? It's amplitude, right?
Yep.
Tell me if you haven't heard that, because I don't want to go through this whole thing. I can do it the algebra 2 way only. What we would call that in algebra 2 would be a vertical stretch.
Right.
Correct?
Yeah, my teacher did amplitude,
Okay.
but he said that both of those are the same.
They're the same thing. That's why I don't quite understand why trig goes to the bother of changing the names. Okay, let's look at B. Actually, let's look at the next easiest one, which is D. What do we call D in algebra? It's a vertical
shift.
It's a shift because it does not change. Whoops, I have to put an F in there. It does not change the shape of the graph, because all it changes is whether it's moved up or down. Okay. Whereas A, the amplitude does change the shape of the graph. If I take a cosine or a sine graph like that, and I at a big amplitude, it does that, changing the shape of the graph. Where
Right.
as a vertical shift, if I start with my sine wave and I decide to move it up 5 units, looks exactly the same. Doesn't change shape at all. So much in the same way that with polynomials, you have vertical shift, horizontal shift, vertical stretch, horizontal stretch, and you have reflections. And this is exactly the same. Okay? What is
All
C
right.
called? What is C called in a polynomial?
That's the horizontal shift, right?
It's called a horizontal shift in algebra, but in trig, it's called a phase shift.
Yes.
Same thing exactly. You move it left or right. If C is a positive number, you move everything right. That also does not change the shape of the graph. C and D, neither one of them change the shape of the graph. Which leaves us to B. In algebra, that would be called a horizontal stretch or squeeze, depending on whether it's above 1 or less than 1. Same thing for amplitude. That could be called a vertical stretch or a vertical squeeze.
Yep.
Okay, so that's what we're dealing with. In other words, you don't need to think of this in trig terms at all. You can just think of it strictly in terms of a polynomial that we're translating. Okay?
Okay.
So, if we take the first one, cosine x, that we think of as the parent function. So, what does the 2 do?
It's a vertical stretch, or that's the amplitude.
Good. Either answer is correct. What does the minus pi over 2 do?
Um, oh, that's the horizontal shift.
Which
Left?
actually
Left.
to the right. Remember what the standard is. And this doesn't matter whether you're dealing with polynomials or anything else. It's x minus c. In this case, c is a positive pi over 2, correct?
Yes.
Positive means to the right. Negative means to the left. The only thing is you have to make sure you understand that. And remember what I told you, that everything prior to calculus is x minus. If I'm looking at the vertex format of a parabola, it's x minus h. It's plus k, but that k originally was on the other side of the equation, and it was y minus k. So pretty much anytime you have to memorize a standard, it's going to be x minus something. If you're looking at circles, it's x minus h squared plus y minus k squared. There is no place where you ever see x plus h or x plus c. Okay.
Okay.
So always know that this is a little strange, that c is the positive pi over 2 here. Okay, now what is the plus 1?
Vertical shift up 1.
Good. So you could graph that. They don't ask you to, but they just want you to describe it.
Yes.
I'll do it real quick. I'm good at these things. There's the cosine curve. There's twice the cosine curve. There's the cosine curve shifted pi over 2 to the right. And finally, the final answer would be that blue curve shifted up 1 unit.
Okay.
So that's how you would graph it, one piece at a time, one change at a time. Now, in reality, that goes all the way to there, and in fact, it continues. You know, these curves, when I draw them, I only draw one period of them. I don't draw the whole curve.
Okay.
Okay. What next one are we doing?
41.
Okay, now here they want you to graph it. Okay, and the parent function is pretty easy to figure out. It's cosine x. Okay, so
Okay.
let me see where the best place for me to graph that. Right there. It's pretty good. I'm going to graph cosine x, exactly one period of it. What's that number right here? What's this number right here?
1 or
-1.
-1.
What's the period of this? In other words, there are 4 key points you want to label. Actually 5.
Right.
It's called the 5 key points of any sinusoid function. What's the last one? In either degrees or radians. Have you gotten to radians yet? Must have, because they're giving them to you in radians. Pi over 2 is a radian measurement.
Yeah, it's so far we've only done radians.
Okay. So that's 2 pi. In other words,
Right.
the parent function's natural period is 2 pi, and that's true whether it's sine or cosine. Tangent, it's only 1 pi. But sine and cosine are both 2 pi. Now, if I split that thing up into 4 parts, which you generally want to do anytime you're doing these, that's pi. That's 3 pi over 2. Notice these are the quadrangles of your unit circle. And that's 0. Okay? So that's my basic parent function, cosine x. Now, always do reflections first. What's the negative sign in front of cosine mean?
So that's
Kind of a reflection is it? Is it over the x-axis or the y-axis?
y.
No. If it is outside the function, it's always a vertical move.
Okay.
If it is inside the function, it is a horizontal. And that deals with anything. That up there was inside, right? That was horizontal. That was outside. That was vertical. That was outside. That was vertical. This negative sign is outside. Inside would be cosine of negative x. Okay? So this is a vertical reflection, which is the same thing as reflecting over the x-axis. Only reason I call it vertical is because it matches up nicely with all your other vertical transformations. There's 6 transformations, you really want to kind of think about them. There's 4 vertical, there's 3 vertical and 3 horizontal. Okay, so the blue or the negative sign I will draw in blue. Strictly a reflection of that. Doesn't really change, it changes the shape only in that it turns it upside down. Okay, so that is that part. And the last part is what?
Up 1.
Up 3. We're on 41, right?
Yeah, sorry, it looked like a 1.
That's okay. I got it covered up with ink. So we're going to take our blue curve move it up exactly 1. So instead of starting at -1, it's going to start there. And instead of ending at +1, instead of ending at -1, it's going to end there. And other than that, it's going to look exactly like the blue curve. It's going to go all the way up to 2. I didn't mean to change the shape. It should be exactly the same shape as the blue curve. And that's how you do it. Now, notice if I would have done my vertical shift first before the reflection, I would have gotten a different curve. If I would have waited till the end to do the vertical shift reflection, I would have been below the x-axis. So you always do all your negative signs first. Doesn't matter which order you do them in, but if I've got something that looks like this, negative cosine of negative x plus 6 times 2, I do that one and that one first and second. Then I do everything else, and it doesn't matter what order you do everything else. Just always make sure you do your reflections first.
All right.
What else we got?
So the next one is 48.
Okay. Here, the basic function f of x is sine x. Well, we've got a lot of things going on here. Go ahead and describe them first. What's the negative? Well, I tell you what, I'll have you describe them as I do them one at a time. Now, you don't have to do these one at a time, but I would certainly suggest it since you're just getting accustomed to it. Once you've taken a full semester of trig, you can kind of do them all at once, although even that's kind of difficult. It's best to do them one at a time. You said 48, right?
Yes.
Okay. So we're going to do the reflection first of the sine wave. Let me draw a nice little sine wave, and I'll make it kind of small because I see we're going to vertically stretch it by quite a bit. The basic one, just like the cosine, it goes between 1 and -1, goes out to 2 pi. That's pi. I label these because you almost always need them if you're dealing with phase shifts, and this one's got a phase shift in it. Now, first thing I'm going to do is reflect it.
All right.
Let's be color consistent here. So that takes care of that.
Okay.
Now, there's two ways to handle the phase shift. One way is to do it last. In other words, draw everything without the phase shift and then just throw in the phase shift. And that's probably the best way for you to do it now. There's a more efficient way, which I like a lot better. And once you get used to it, it works a little quicker, but it requires a lot more trick. So let's just do it one step at a time, and we'll do the phase shift last. So let's do the 5. What's the 5 do?
That's the amplitude.
Which is what in terms of algebra terminology?
Vertical stretch.
Okay. Does change the shape. Unfortunately, I didn't give myself quite enough room here, so I'm going to have to draw it a little funky. Okay, so I'm taking the blue curve, and I'm just stretching it. to 5 to minus 5 and up to plus 5. Didn't change the period. Period stayed the same. Okay? The period would only be changed if there was a number after sine. If it said sine of 2 parentheses, then that would have the effect of stretching out the period. Doesn't look
Right.
like they're giving you any of those yet. Where you have horizontal, where you have a change in the period. Okay, the next thing to best handle is probably the vertical, because we want to do the phase shift last. So the vertical shift, what am I going to do? Which color curve and what am I going to do with it?
So it's gonna start back at pi over 2.
No, we're talking about a vertical, that's a vertical shift. So let's talk, we're going to start at 0 because we haven't applied the phase shift yet.
Oh, sorry.
So if I'm doing a vertical shift, I'm going to start here and everything's just going to be shift. Excuse me, that's not where I'm going to start. Let's talk about this over. First of all, there's always a horizontal line of symmetry. And
Right.
you recognize what that is. That's the middle of your curve. Not quite the way I've drawn it, but I think you get the picture.
Yeah.
When you apply vertical shift, what you do is merely move that up 3 units. Okay?
Okay.
And instead of being at y equals 0 as a starting place, we're going to have everything centered about this line of symmetry. Let's go ahead and draw it in. And now we are taking, what's the last thing we did? Applied the green. So we're taking the green and we're moving it up 3 units. Right now the green starts at 0. Now it's going to start here. And how far down do I go? In other words, I know I go down, the green goes down, but what's my bottom point? What's that label going to be?
That's gonna be -2.
Yes. In other words, it's going to be 3 units higher than -5. And this one I've got labeled correctly. Yeah, no, we're okay. Okay, so the best way to draw these curves is kind of using points. I know that's my starting point. I know that is my pi over 2 point. I know I got to come back and go through the x-axis and go 5 units higher than 3. So I've got to, oh, don't tell me my pen went out on me. Oh, that's terrible. And let me try a quick unplug and replug. I'm not sure. How many more problems do we have to do, Dimitri?
One more, I think. Yeah, after this, one more.
Well, I need this. Let me try a quick thing here. And let's just see if my pen is working now. I doubt it will be. May require me to do
Oh, crap.
extraordinary things. Yeah. My pen is not working. Why'd you say, oh crap?
We did the wrong problem. It's supposed to be 46. I wrote it, and it looks like an 8.
Okay.
Actually,
Well, that's okay. We didn't even quite finish 48 yet. 46 also has a phase shift on it, so we're going to have to do it over again anyway.
Okay.
I'm trying to think of my quickest way to get back in action here. Let me try this one more time. Sometimes I have to reboot my machine. That's what it looks like I'm going to have to do here. Can I hate to do this, but can you give me 3 minutes to reboot, and I'll have to send you a new meeting ID number?
Yep, that's fine.
Okay, I'll talk to you shortly.
Okay.
Bye-bye.
Bye.